Acceleration of block sliding down an inclined plane. So we have this inclined plane, angle of inclination is theta, and we have a block which is going down the plane. So the direction of velocity is down the plane. Incidentally, the direction of acceleration will be also in the same direction, which I'll explain in a little while. So how do we find the magnitude of the acceleration? We use the Newton's second law, F is equal to m into a. So step one is to identify what is the net force which is acting on this block. Before that, we need to draw the free body diagram. So if you analyze what are the different forces acting on this object, the first force is the obvious weight going downwards. We have the normal reaction which is perpendicular to the incline. If the inclined plane is rough, which means friction will come into play, and the direction of friction is opposite to the direction of velocity. Now, since the block is going down the inclined plane, direction of friction will be up the incline. So have a look. We have three forces mg downwards, normal reaction perpendicular to the inclined plane, and the friction, which in this case is kinetic since the object is actually slipping on the incline. The direction of friction will be opposite to the velocity. So that's the step one, identifying the different forces. Step two, how do we figure out what is the net force acting on this object? So for that, we will break the mg into two components. So the component which is perpendicular to the incline will be mg cos theta, and this particular component will be mg sin theta. And how are we doing this? Because if the angle of inclination is theta, then this particular angle over here is also theta, this small angle. That means the component which is perpendicular to the incline will have the cos parameter, so mg cos theta, and the other component will have the sine parameter, so mg sin theta. So we already know that in situations like this, if a block is kept on an inclined plane, for the block to start moving, there is a critical value of theta which needs to be satisfied. And that is, for the block to start moving, the angle of inclination theta should be greater than tan inverse mu s. Only then the block will start to move. Now, in this case, it is mentioned that the block is actually sliding down the incline, which means the angle of inclination is much greater than tan inverse mu s. So now we have to figure out the magnitude of acceleration using the Newton's second law, F is equal to ma. So acceleration will be equal to the net force divided by m. So what is the net force acting on this object? So if you analyze this picture, the normal reaction will cancel out mg cos theta. So there is zero acceleration perpendicular to the incline, but there is an acceleration along the incline. So we have one force mg sin theta going downwards and the kinetic friction going upwards. Since both these forces are in the opposite direction, we will need to subtract it. So mg sin theta minus kinetic friction will be the value of net force. So F net is mg sin theta minus Fk, and the formula for friction, if you remember, is mu times the normal reaction. And in this situation, the normal reaction is actually equal to mg cos theta. So if we combine these two expressions, so the friction will be mu times mg cos theta, which we can put in the formula. So the net force will be mg sin theta minus friction, which will be mu times mg cos theta. So that is the net force. Now we will divide the net force with mass to get the acceleration. Hence, acceleration is F net upon m. So the entire expression needs to be divided with m. And now if we simplify, we will get acceleration as g sine theta minus mu times g cos theta. So this is the acceleration of a block which is sliding down an inclined plane. So let's summarize. Whenever we have questions which deal with blocks which are sliding down an inclined plane, we need to remember the direction of acceleration is always along the incline and going downwards, and the magnitude will be g sine theta minus mu times g cos theta. This is assuming that the inclined plane is rough, so which means friction is there. Imagine a situation if the inclined plane is smooth, so there is no friction at all. In that case, we can take the value of mu as 0. Mu 0 means it's a frictionless surface. Then the value of acceleration will be just g sine theta. So depending on whether the incline is having friction or it doesn't have friction, the value of acceleration will change. So these are the magnitudes. Now, the direction of acceleration in this case is down the plane. And that is because the net force acting on the block is down the plane. It was mg sine theta down. minus the kinetic friction. If you remember, that was the net force acting down the plane, and hence acceleration is also down the plane. Now we will analyze the same block, but imagine instead of sliding down, it is actually sliding up the inclined plane. So that's the next title: how to figure out the acceleration of a block which is sliding up the incline. So the diagram stays the same. We have a block kept on an incline of angle of inclination theta. So we will apply the same steps. Step 1, draw the forces acting on this object. So we'll have weight mg acting downwards. We have normal reaction going perpendicular to the incline, and friction, of course, will be there since we are assuming that the incline is rough. But the direction of friction is very important. Since the block is now sliding up the incline, the direction of friction will be down the incline since it opposes the slipping motion. So step 1, let's draw the free body diagram. Mg acting downwards. Normal reaction is perpendicular to the incline, and kinetic friction will be along the incline but going downwards. So like in the previous case, we will break the mg into two components, mg cos theta and mg sin theta. Now again, all we need to do is figure out the net force. So acceleration is net force divided by m. Now if you analyze the forces which are perpendicular to the incline, n and mg cos theta will balance each other out. So n is equal to mg cos theta. So the net force acting on the incline will be mg sin theta plus the friction, because in the previous case we had subtracted, remember, because the mg sin theta and kinetic friction were in opposite direction. But in this case, mg sin theta and kinetic friction, they both are acting in the same direction, down the plane. So we'll have to add to get the resultant. So the net force will be mg sin theta plus fk. Fk, we know the formula, mu times the normal reaction, and in this case normal reaction is equal to mg cos theta. So now if we combine all these formulas, net force will come out as mg sin theta plus kinetic friction, which is mu times mg cos theta. Now let's put the value of net force in the formula for acceleration, which is net force divided by m. So if we divide the expression of net force divided by m, we will get the acceleration as g sin theta plus mu times g cos theta. So this is the acceleration of a block which is sliding up an inclined plane. So of course, this is the magnitude. Direction of acceleration is down the plane. Why is that? Because if we recall, the net force is mg sin theta plus kinetic friction, and the direction of net force is down the plane. That is why acceleration will also be down the plane. So we can say direction of acceleration, even in this case, will be down the plane. And now let us summarize the two cases. Case 1, acceleration of a block sliding down an inclined plane. So in this case, we need to remember the formulas. Acceleration is g sin theta minus mu g cos theta if the incline is rough, otherwise it is g sin theta. In case of the block which is sliding up, then the acceleration will be g sin theta plus. So the formula is similar, but instead of minus sign, we have a plus sign in the middle. For this is the expression for if the incline is rough. If the incline is smooth, then the value of mu is 0. So the acceleration will be g sin theta. But please note, no matter the block sliding down or up an inclined plane, the direction of acceleration is always down the incline. In this question, we have a block kept on an incline, and the three forces are already shown: the weight, the normal reaction, and the friction. So we need to determine which case is this. Is the block sliding up the incline or down the incline? So if you read the question carefully, it states that the block is sliding down and we are supposed to find the acceleration. To find the acceleration, the formula is acceleration is net force divided by m, which is the Newton's second law, F is equal to ma, which means to find the acceleration, all we need to do is figure out the net force acting on the object. And for that, we need to draw the forces, which the question already has done. So weight acting downwards, normal reaction, and friction. So first, we will figure out the net force and then we will try to figure out the acceleration. So how do we do it? Let me explain this making a proper diagram. Acceleration of block sliding down an inclined plane. So we have this inclined plane, angle of inclination is theta, and we have a block which is going down the plane. So the direction of velocity is down the plane. Incidentally, the direction of acceleration will be also in the same direction, which I'll explain in a little while. So how do we find the magnitude of the acceleration? We use the Newton's second law, F is equal to m into a. So step one is to identify what is the net force which is acting on this block. Before that, we need to draw the free body diagram. So if you analyze what are the different forces acting on this object, the first force is the obvious weight going downwards. We have the normal reaction which is perpendicular to the incline. If the inclined plane is rough, which means friction will come into play, and the direction of friction is